Hello friends, this is Kevin, which is just a sound that defines who I am, and I'm going to go over question 10, homework 8. This one is incredible. Okay, so for A, recall that rotational inertia is mr squared, or mass times the distance squared. And this is actually pretty easy if you know what it's asking. So we do know the masses, but how are you supposed to find the distance? Well, we're being told that it passes through the midpoints of opposite sides and lies in plane of the square. So think about it. What would that look like? Midpoint, opposite sides, and in the same plane. It's really just saying it's going through the middle. It's parallel. It goes through the middle of two opposite sides. It's in the same plane. So this blue line is the rotational axis. So we know our masses of each one is given to you. So what's the distance of each mass from the rotational plane? Hopefully it's obvious, and it's 1/2 of the distance between each point. In my case, it would be 1.17. So then the rotational inertia for each mass is just the mass of it times by half of the distance between each point squared. And that's for each mass. And since you have 4 of them that are exactly the same mass and all the same distance from the rotation of inertia, you just multiply by 4. So 4.96 in my case with my numbers. Alright, for B. Same process, much more difficult to visualize. So we're being told it passes through the middle of one side and perpendicular. So this is what it would look like. It's in the middle of one side, and if it's perpendicular, that means, and imagine for a moment that this blue dot is a line that's currently going up. It's pointing out of your screen. It's pointing towards you. It's perfectly perpendicular. So then what's the distance for each red dot from this blue point? Well, for these two, it's pretty obvious. It's just 1/2 again. Well, what about these 2 points? What's your R for these two? Well, that's where we use our Pythagorean theorem. It's back. See, the distance from these 2 points is just the distance between the 2 red points squared plus the distance between the red point and this blue point squared, square rooted. So we can write this as a squared plus b squared equals c squared. And remember, in our formula we're being asked for mass times distance squared. C squared is a distance, so you actually don't need to take the square root of it like I just did right here. You can just take this squared and this squared and then use that as your mass. Use that as your r squared. So then whatever you got from this times this squared, you times that by your m, and that's the rotational inertia for each point. You have 2 of those, so you multiply by 2, and then you add it for the inertia for these 2 that you got from before. And here's my work if you want to go through it. Now C. There's a way to calculate this directly like A, but and I don't want to explain it. It's through slander, because there is a much better way to tackle this problem. So rotational inertia, think about it like as a concept. And in its units, it says mass and the r squared. R squared is just the distance squared. It's just talking about the area. It's just talking about how far away the weight, how far away the weight is from the center. So for C, we're being told it's cutting the same square in a diagonal. It's splitting it in half equally, and everything's the same distance away. How is that different from part A, where it splits the square equally and the mass is the same distance away? The square did not change its dimensions. The area did not change the dimensions. Half of the mass did not change its dimensions. Did not change. Half of the mass is still on both sides. And the average distance could not have changed. It's the same shape. It's being cut up into the same equal pieces. This means overall, the mr squared is exactly the same as long as you're cutting it in half. It does not matter how you cut it. Because in physics, I guess how you break things up really doesn't matter. As long as it follows the formula, which is half of the mass is on one side, half is the other, it's the same result. So without even doing any math, you know for C that it's going to be the exact same thing as A. 100. But if you were to look at this guy's explanation on Slader, which is a great site, you don't need to pay, they go for the work, and the distance for each point, like they do it by each corner again. That's fine, but each corner, they won't be the same. But overall, it's still the same, because half of the mass is still on each side, and the dimensions still stayed the same. The area is still the same. And the only thing that matters is the distance squared, r squared, which is just area, and mass. Those two things do not change. So that's why a C is exactly the same as A, and I wish I realized that sooner.